Of course, that's where I'm in.
Hey, you okay? Okay. So, today, thank you. So I've put the link for the stream in the Slack, so you can go on that now. I think I put the wrong link in there yesterday. But really, that's going to be more important when we start doing Visual Studio in this lecture, because you'll need to see it properly that way. I'm just going to turn this on. Right. So today's lecture, there's, well, two lectures. Firstly, we're going to be talking about C#. This is like the final build-up to, I think a lot of you are kind of concerned that we're going to jump off a cliff next week into the hell that is ASP.NET. So hopefully this is just kind of our last little step towards that. So we're going to look at C#, look at the coding conventions, which are important for you for your coursework, and I'm going to talk about how we do code reviews, because remember, part of your coursework is to actually do a code review of each other's code. So C#, there are lots of .NET languages you could use. One of the key things about .NET is that you can work in pretty much any language that they support, and then it gets compiled to a common language at runtime. But C# is probably the most important language. It's currently the leading language in business applications for Windows, at least, web development, and game development. The web development one is kind of always changing, but game development for sure. I keep saying this, and I'm going to keep saying it. C# developers get paid more. That's just a fact. You can look it up. It's like 5 or 6% more on average or something like that. And that's why I think it's essential that you learn some C# before the end of your course. And that's why we have it in this module. But C#, because there's so many people that use it, there's lots of support online for the language and lots of good communities. I really like C#. I think a few lectures ago I said, I love programming, and C# is one of my favorite languages to work in. I think mainly because I work in it the most. I rarely go 2 days without coding something in C#. And you find, I think anyway, C# is a nice language to work with. It's very much built for Visual Studio. So when you're working with Visual Studio and C# together, everything kind of works. The IntelliSense, autocomplete just is nice. And there is nothing better than having like a nice mechanical keyboard, a mug of coffee, and just sitting down and coding for like 2 or 3 hours straight with C#. It just feels good. And when you get good at this stuff, you will hopefully find a way of enjoying that, of getting into almost like a flow state coding, because you're so used to a language. It's not going to be like that for a few weeks, because you have to go through this horrible phase of not knowing what you're doing and learning. And that is challenging, and it's difficult, and it's horrible. But at the end, you just start to get it. And it's important you get used to that, because you're going to go to different jobs, and then you might go to a job and they tell you, oh no, we don't use C#. We use this random language you've never even met. And you're going to go through that so that you just get used to it. It's like learning like written languages, right? Once you've learned a couple, you get very good at just learning new ones. It's the same with programming. This lecture, I'm going to be kind of throwing C# concepts at you. I don't necessarily expect you to be able to remember them at the end of this lecture, but if you've seen me talk about them, it will sit somewhere in the back of your mind, and you'll know there's something there is a technique there. You'll hopefully remember that a technique exists, even if you don't know how to use it. And then this set of slides is something for you to go to and find where is this technique and how do I use it. So it's going to be quite a fast, like, this is something you can do, this is something you can do, this is something you can do. But then hopefully over the next few weeks, as you're working in C#, you'll remember to look back at these slides and say, that's how I do that. But you will as well need to do some learning and research yourself. And that's kind of an essential skill, like going on Stack Overflow and figuring out if this person's problem is the same as your problem is an important software engineering skill. And that's something that you will be getting from this module. So let's start with the basics. Firstly, the closest kind of relative to C# probably is Java. So hopefully most of you are comfortable with Java, and you're going to be then, you'll probably find it's not hugely different. So firstly, we've got to go through like the very basic foundations of the language. Firstly, it's case sensitive. So those two variables are different. Keywords are always in lowercase. So if we have any kind of ifs, fors, for eaches, we write it in lowercase. This is part of the coding conventions that I talked about. Private variables should start with lowercase. We use camel casing. But private variables always start with a lowercase letter, and public variables start with an uppercase letter. And that's a very easy way. The coding conventions, hopefully, did you guys do Bob's coding convention stuff? I don't know if someone else does that now in year 2. But the reason we have coding conventions is that when you go to a team that you haven't worked in, they will be following a set of conventions that will allow you to quickly start working on their code. It's like a language. So one of these kind of languages is every public variable starts with a capital P, with a capital letter, and you immediately know that's a public variable and the other one's a private. So we can comment, obviously, and block comments are supported with the kind of hash, the whatever you call that, asterisk, I guess, symbol. And we can put statements across multiple lines, and we need to terminate them with a semicolon. So as a general rule, what you should be thinking as you're doing your coding is, if I have a standard widescreen monitor and you can split Visual Studio so you can have 2 source codes next to each other, you want to have it so no line of code goes beyond there, because you're going to be constantly having two files open at the same time, trying to edit them pretty much both at the same time. And so what you need to do is you need all your lines to be able to fit on that half of the screen. It's just a general, it makes your code cleaner, it just makes it look nicer, easier to read. And then we have block structures. So block structures such as an if statement or a loop, they're contained within curly braces. There are a bunch of different data types. Like you'll learn them as you need them. So all .NET code. So you're writing it in C#, but then what happens is that C# is compiled to this common language, and so the type becomes a slightly different type. And these data types might have different names in C# or in whatever other Visual Basic, whatever other language you're using in .NET. They might have different names, but they end up being the same data type. And there's a table there for you to look at sometime when you need it. So the order I'm going through these slides, I've tried to make it a relatively logical order, but it's a lot of little bits. So these lecture slides might not follow on necessarily naturally. So one data type which you should be aware of, which is incredibly useful, especially for web applications, is something called an enumeration. So an enumeration is a group of related constants that are corresponding to an integer. Each one corresponds to an integer. So for example, we might have something where we've got a role. So you can imagine a web application where you have some kind of differing roles between your users. One way you might think of implementing that is storing your role type as a string and saying if role type equals and then a string student, then give the user the student stuff. There's a bunch of problems with doing it that way. Firstly, you're doing a string comparison, and a string comparison is like going character by character and checking each one is the same. So if you have a string that's 5 characters long, that takes 5 times as long to compare as 2 integers would. So that's one reason. The other reason is if you're writing your code out and you want to do a check to see if a user is a lecturer, you might do a typo, misspell it, and then it won't work. And the compiler you wouldn't get a compile error, you wouldn't get any warning from Visual Studio because it's just a string. It wouldn't know that you've used it that way. So what you have is you have this data type called an enumeration. And you define it like this. So we define our data type as a role type. So enum role type. And we say role type can have 3 values, lecturer, student, or admin. Then we can just create a role, a variable here. So role type role equals role type, which is this type here, dot lecturer. And then autocomplete, as soon as we do that dot, we'll get the choice of one of these 3 types. And that means you can't make a typo because you just push the dot and then it appears there. This is what's really good about this data type is it's actually an integer. There's just this layer there for you to help you on top of it. So lecturer, actually, you can cast that as an integer. So, and it would be 0. So the way that it casts is that lecturer would be 0, student would be 1, admin would be 2. And what this allows you to do is actually create arrays and access elements of arrays using a role type. Because it's an integer, actually. Deep down it's an integer. So you could have an array that is role type strings, which you've created is like how a human readable description of each of those role types, and say in your application you want to say your role type is student, you could have that array of strings and just do my array square bracket role close square bracket, and that would give you, it would access the array like a normal integer. It's one of those things that as you start coding, you will start thinking, oh, I can use this for that. And you'll start using it a lot. So object-based manipulation. I have said, again, lots and lots, this module is more about object-oriented programming than it is about websites. And .NET is object-oriented right to the core. Even ordinary variables are actually full objects. Most common manipulations you would want to do have associated methods. So for example, if we define a string and an integer, just as data types here, an integer isn't just a number, it's actually an object. And so what we can do is integer will have a bunch of methods involved in it. So what we can do is we can say myInt.toString, and that is a method that the class int has. And the fact is, most of the common things you would want to do, like another one that you see a lot of is with strings, there is a method toUpper or toLower, which changes the case of the string. So things that you might think of doing yourself, or maybe you write your own kind of JavaScript stuff to do it, or whatever, Java, it's in there as methods of these base types. And again, no one would expect you to memorize these, but Visual Studio is really good at autocomplete. So what you end up doing, most of how I would code is I would type in whatever my variable is, and I think there's probably a method that does this, and just push full stop, and it will give you all of the methods. And you just go through, and these are really well written. The methods are descriptive, and then it's just a case of Googling it. Maybe you don't even need to do that. So the basics of classes. So this is a class I've defined. You're going to be working with classes. That's just what you're going to be doing. Classes contain properties, methods, and events. Don't worry too much about the events thing. It's not something we'll be using. So on this class, I've defined a class vector2d. I've defined two properties, x and y. So we're talking about a vector that I might be using in a game engine, probably, or a graphics engine. Don't talk in my lecture, all right? So there's two properties here, x and y, which are your x and y values of this vector. This thing here, get and set, is a syntactic sugar that C# has that a lot of languages don't have. So when you're working in Java, you'd write getters and setters for your properties. In C#, just writing get and set here creates what we call the default getter and setters. So you don't have to actually manually write a getter and setter for each one. Now it's important, so depending on what framework you're using, if you're working in Unity, you don't normally see these, because the way the Unity engine and framework works is it doesn't want you to set those getter and setters. If you do, it messes up things in the inspector when you're working in the engine. Whereas with ASP.NET, those with MVC, sorry, the stuff we're going to be doing, setting those is important because the framework needs the default getter and setters to do some fancy stuff to do with databases. So that's, if you're having problems with stuff, it might be because you haven't put those in. Because it's got these getters and setters, we call it a property. So that's, if it's a private, we would usually call that a field. So a field would be a private variable. Public variables, we say properties. So we set up a constructor. So a constructor is a public method that has the same name as our class. And we could have a load of different types of constructors using something called overloading, which I'll explain later on. But in this case, I've got a constructor that takes in x and y. These are lowercase because these are going to be local variables to this function or method. And then all I'm doing is setting x and y here. And the default getter and setters, the way they actually work is they overload the equals function. And so we don't have to do like vector2.setX, right? It's overloading these so it looks easier. And then I've got a public method here that returns a double and it's getLength. So it's just doing it's using some intrinsic functions here, the math class, square root, and it's finding the distance and returning that. Then once we've created this class, we would instantiate it like this. So here I'm doing an inline definition of it. I'm assigning this variable kind of inline in my function. So vector2d vec equals new vector2d and then 1, 2. This keyword new here is saying we're creating something new. We need some memory to allocate for that. We can then find the length. Same here, using that method that I defined. We can change x very simply because we've got those default getters and setters just by doing equals 2. Then here I'm creating a second vector. Because I haven't said equals new vector, this isn't going to be a null. This will be null because I haven't actually assigned it anything. Now if we do this and we say vector2 equals vec, the first one we created, this doesn't actually create a copy. What it does is it points vector2 to vec. So if then we were to change vec, vec2 would also change. And that, a lot of people get caught out by that. If that isn't what you want, if you want something that copies a vector, so let's say you've got some vector here and you want a copy of it, but then you want to change that somehow, you need to write your own method to do a copy. And you would write a method in the vector2d class that actually returns a new vector. And then you would be like vec2 equals vec.copy. So static parameters and methods are really, really powerful things. So static anything that's static can be retrieved without instantiating an instance of that class. So here, I've created a class, and I've created this static int of instances. So imagine a situation where I want to keep track of how many classes have been created. The easiest way, I think, to think about this is imagine you're making a game and you want to know how many enemies there are at a given time. A naive way of doing it would be every frame you count everything. So you do a search and you say, right, go, how many enemies are there? The better way to implement that is like this. So we have a static variable here, instances. Now, because it's static, this value is kind of associated with this class. It's not associated with a single instance of the class. It's just associated with the class as a whole. And then what we do is we have in our constructor here, I increase instances by 1. Because I've started it at 0, when the program starts, it will be 0. So we'll launch the when we start the program, instances will be set to 0 because I've put it here saying it's 0. Then what this is, if we do tilde my class, that's a destructor. So it's the opposite of a constructor. When we delete my class, it will actually run this method. So what we can do, and then we can do another, we've got a static method here. So it's not just properties that can be static, we can actually have static methods called getActiveInstances, and it simply returns instances. So then what happens is we can, if we create we instantiate 2 my classes, each one will run this, which will increase the static int that's counting how many. And so this will just be telling us how many classes we've got. Then, without instantiating a new one, we can actually just access this method by typing my class, which is the class name, and then you do dot, and then all the static methods will appear. So then we say get active instances. Yeah?
So that destructor, is that called after the end of an instance of my class?
It would be if you did something like delete my class, then that would be called, yeah. So if you ever destroyed something, one thing about C# and working in .NET is we can just create and destroy objects as we wish, because it's managing the memory for you. So yeah, so as soon as something gets destroyed, that would be called. In your web application, it might be that a user is visiting like a page, that's created a controller class, which somehow I'll talk about later, and then when that user leaves, that controller class will just be destroyed. It will also be called if the whole program is closed. So when if it's exited correctly, rather than like Alt F4ing it, right? So if you actually exit the application, it will call those things. Yeah?
Is there a standard method to destroy an object?
I'm pretty sure it's just destroy. Or you could reset to null. To be honest, I don't actually know. It's not something you tend to have to do. You'd normally be freeing memory somewhere else. So you'd just be setting it to null or something.
So that the tilde my class runs when you set an object to null?
I believe so, but I would check that. What you tend to find is when you're working with the framework will have its own way of destroying an object. And then you would call that, and then it would be doing that kind of thing. So, methods are kind of your most basic building blocks for organizing your code. All methods start with uppercase, so it's not like properties where you have uppercase for public and lowercase for private. Declaring methods requires that you define their visibility. By default, all methods are private, so they can't be seen outside the class. The type of data that method returns, the method name, and then parameters it takes in. So here, we've got a private method. The keyword here, void, means that method returns nothing. So that means it just does something with stuff inside your class. It's not returning anything outside. This method returns an integer and is public. So we're just returning a number. So as soon as we write the keyword return in a method, the method kind of yields control to whatever called it. So if you've got a series of lines in a method that calls another method, It's going to go into that method until it sees return, and then it's going to come back out. That becomes important when you start debugging line by line using Visual Studio. This method then adds two integers. So it's got parameters here, so v1 and v2, adds them together, and then returns it. So we can have any number of parameters defined there, but we need to define the type and what we call it. In terms of software engineering, your job is to make sure every method does one thing. And what that usually means is you write a method and it will be long and awful and horrible, and then you think, right, what bits in this big mess of code that I wrote can I separate out as its own thing? And you make it so everything has its own job. There are lots of really good tools in Visual Studio to help you do that, and I'll be showing you that in the next few lectures next week. And that's something I want you to be looking at each other's code in a code review, because you'll probably find if you do that, you can reuse those methods in other things. Method overloading. C# supports you creating more than one method with the same name but different parameters. Then the common language runtime picks the correct method depending on the parameters that you supply. So for example, let's say we've got some kind of system that is like a HR system, and we want to get the age of an employee. Well, we might have the employee's ID, or we might have the employee's name. The ID might be an integer, and the name might be a string. So what we can actually do is write the same method, get age, twice, but if you look, they have different inputs. Okay? And likely what we would do is some kind of code here that converts probably ID. We just get that from a table. But string name here, we probably have to have some code to convert that name to an ID. And then we probably call this method, actually. We can probably call the one that already exists. And this is really powerful. And nothing like this, I think, is one of the most powerful features. And when you really understand what this is doing and how this is working, you'll use it all the time. You need to understand this concept of a method's signature. So a method's signature is the thing it returns, the name of the method, and the input parameters. We can't define two methods that have the same signature because the compiler won't be able to tell the difference between them. But we can have methods that have the same name but have different signatures. And then in our code, we can use the appropriate method depending on what parameters we have, and then the compiler will be able to select the correct one based on that signature. We can use named parameters and optional parameters, which is very similar to overloading, but in reality this isn't as good practice, as we prefer to use overloading. So for example here, I could have a second parameter, use short form equals false. Because I've said equals false, I've basically given the compiler a default value. So I'm saying if there is no value, if they haven't put in a value for use short form, just assume that it's false. And you can have multiple optional parameters. And if you've got multiple optional parameters, then you can do this kind of style of, you have to then tell it, because maybe you've got 5 optional parameters and you want to set the 4th one, but not 2 of them in between. Well, then you actually use this kind of notation. You see this more where you have a function that has like maybe 10 or 20 inputs, and maybe then you would want to have lots of optional parameters. But in best practice, as a rule, unless there's a very specific reason, you should use overloading. Delegates is an interesting feature which allows you to have a variable that points to a method, and then you can change the method that variable points to. A delegate must point to a specific signature. We can't use overloading and delegates together. So for example, imagine you've got some kind of currency conversion software. You can define 2 methods, pounds to dollars, dollars to pounds, Sorry, the signature actually doesn't include the name of the method. The signature is to do with what comes in the parameters and the outputs. So that defines the signature. The name is something different. So you can have methods that have the same name, but they've got to have different signatures. So these two methods have the same signature. This one converts pounds to dollars, this one converts dollars to pounds, but they both take in an integer and return a decimal. This probably should have been a decimal as well. Now we can define a delegate here. So we say private delegate. So that's like the data type. So it's no different to saying like private int. And then we need to define the signature of this function. So we say, right, we're looking for a method that returns decimal. This is the name of our delegate, and it takes in an integer. And then what we can do is in our code, we can just create a function reference. So this will be a variable in our code that is a version of this delegate. And then what we can do is we can have a method. So here we've got set conversion. It takes in a string. Again, it would be better to do that with an enumeration. But if we say, if that string equals PD, we set this function reference to pounds to dollars. Otherwise, we set it to dollars to pounds. Then we can have a convert method that uses the delegate rather than using these methods directly. So the reason that is useful is we can structure our code in such a way that we could have a convert method here that doesn't need to know if we're converting from pounds to dollars or dollars to pounds. That convert method just calls this delegate that we have correctly assigned to the right method somewhere else in our code. So it's minimizing the amount of code you have to write. Arrays behave like you would expect them to behave. We can define them. We can have two-dimensional arrays, and we write them like this. This is just something reference for you to look back on when you need it. Now, arrays, the size of an array cannot be changed at runtime, but you're often going to be wanting to do that. So you might be grabbing various pieces of data from a database, and you might be adding that to a list. To do that, we use collection classes, which are a set of classes that are in .NET that allow us to create things like linked lists and other things like that. So a really useful class is the generic list. To use it, you'll want to first make sure you're using the correct namespace. So in C#, there is a concept of scope and namespaces. So if we want to use methods and classes from a specific library, we have to say we're using that namespace at the top of the file. Visual Studio is very good at helping you with that kind of thing. It will give you an error, but it will say, oh, but I know that we have this method in this namespace, so I think you just forgot to put your using line at the top of your file. And it will suggest that to you, which is quite nice. So what we can do, so we have a list of integers here. It doesn't have to be integers, it can be anything. So it can be your own classes that you've made. So you do list, and then these kind of triangular brackets. This is a kind of thing called a template class. So it's a class that uses another type of class. So here we can put any type of class in there. We create a list by doing new list of integers. This is just the constructor. And then what we can do is we can just add values to this list. So here we've just taken this, at the moment it's empty. Then what we do is using the add function, we just keep adding values, and it's literally just going to pile these values up on top of each other. We can loop over the members of that list in two ways. We can do a for each, and we can write it using this syntax, where we say for each number in list int, and then do something. And it will loop through, it will say, right, okay, what's the next number, and it just puts it in that variable num, and then we can do stuff. You can also access entries just like you would in a normal array. So we can actually use square brackets and access those entries. And this is how you do loops in C#. This way of doing things looks nicer, but this way actually performs slightly better. And the reason that is because here we're having to create, we're actually creating an integer and deleting it every time we go around the loop. Now with an integer, who cares? Okay, that's not a big deal. But imagine this was a complex class that had lots of data in it. If we were creating and deleting those every time we went around that loop, that has some performance issues. Specifically, it's got something to do with a thing called the garbage collector. Now, C#, we can just create new objects and delete them as we want. But what's going to be happening is the garbage collector is going to be constantly monitoring the memory you're using. And if it sees there's a load of memory you're not using, it will say, okay, I'm going to step in and I'm going to free this memory for the system to be used somewhere else. That operation actually costs like performance. It actually affects the CPU performance. So the CPU has to do some work there. The more you do that, the worse it is. That's particularly important if you're doing game development, but it's also important for web applications because you might have hundreds of people accessing your server at the same time. And if you're not taking care of things like this, that can quickly escalate. So it's just something to bear in mind. It's not overly important for what you're doing, but at some point someone's going to say to you, you're going to run into problems at some point probably with the garbage collector. Not on this module, but in other points in your life, I'm sure. And there's lots of different types of lists. Again, you'll learn these as you start to use them. We're going to be using them a lot. So a few more concepts left now. The virtual keyword. So there's a few things in this slide actually. What we can do is we can define a class, and that class can be a base class. And then we can create a new class that inherits everything from that base class. And that's something you're going to be doing a lot. So for example, we might decide we've got maybe a geometry package or a CAD package that has lots of shapes. Okay, and we need to have lots of ways of defining a square, a circle, whatever. So we decide, let's define this base class of shape. And we have a few variables here. We say we've got pi, because we're going to use that a lot, x and y, shape. So we've got a constructor here. Interestingly here, look, we've got two constructors, but they have a different signature. So that's something we can overload. So we can decide which one of those constructors to use. And then we've got a public virtual area method that returns that. Now, let's say we want to now create a specific shape. So we want to create a sphere. Well, we can have this class sphere that inherits from shape. And by doing that, what that means is sphere already has all of these methods and properties that were in the shape class. It's inherited all of those things. But what we can do is two things here. Firstly, we can define our own constructor for this specific thing. So we can say sphere, its constructor is going to just take one value, and this colon is telling us how it relates to the base class constructor. So what's happening is we're saying, okay, a sphere, the constructor for sphere, just takes in one number, the radius. But we want then that to construct the base class, which is shape, like this. So this r goes into the first parameter, so for x, and the next one's going to be 0. So what this would do, it would set r to x to whatever r is, and then y to 0 based on this. Now this area method, we know every shape we want to be able to calculate the area. And what that means is in our code somewhere else, we can have methods that act on the shape class, but we don't need to know what specific type of shape it is. We just know if this is a shape, we can guarantee the method area is going to be in it. But different shapes have different ways to calculate area, so we need to override this method for this specific shape. And because we put the keyword virtual, we're allowed to do that. So what we do is say public override double area. So we're overriding this method with the specific method for a sphere. And that's it. We need to make sure these have the same signature if we're going to do that, or it returns the same thing. And that means your code can be slightly more generic when you're just dealing with shapes. So you can just deal with shapes, not really caring what type of shape it is, because you know that method area is always going to be there, and you know it's going to work. Now we can only inherit one class in C#, and believe it or not, there might be cases where you want to inherit a bunch of classes. So you want a class to be made up of different things. Now the way we do that is using something called an interface. And again, this kind of, we're getting onto advanced stuff here, but it is important. So interfaces are a way of defining a certain set of methods that you expect to be in a class. So for example, we might define an interface here, iSampleInterface. And we're saying any class that implements the iSampleInterface, you can always tell it's an interface because it starts with I, must have this sample method in it. Then, if we create a new class, we've got the same kind of notation as when we derive from a class, but this means we're implementing, this implementation class implements iSampleInterface, this thing here. And when you do that, Visual Studio will be like, don't forget you've got to implement all the methods that are in that interface. So what it does is it'll automatically say, hey, you've got to implement this method, sample method. So what that means for our code is we can write functions where the parameter can be any class that implements our interface. Okay? And we know that if a class implements this interface, we know what methods it has to have. And so we can just use those methods without really knowing what type of object it is. We just know that that object implements this interface, which means we know these methods exist. The kind of easiest example to kind of get this around your head is this thing, the interface iEquatable. So if an object uses has the interface iEquatable, it must have a method equals. So then what we can do is we could make the equals symbol use this method equals. So when you check if two things are equal, we can say, right, we know that as long as you've implemented this iEquatable interface, we have a method equals that will check if this object equals another object. And you should know that, like, if it's an integer, that's easy to figure out, but if it's a complex object, the idea of are these two things the same might be more complex. So again, like, as we use this stuff in the course, this will become clearer. I'm just kind of throwing this at you so you've got this idea in your head. The final thing to talk about C# is asynchronous programming. So I bet you thought I'd avoid all the kind of Ben's modules and stuff to get away from multi-threading and all this kind of thing. But we're going to be doing that here. Because the reality is, asynchronous programming is essential to web development. Because you might have some code that you have a line of code, and what that is doing is it's going off and requesting some data from a database. And that might take time. You don't want your code to stop, freeze, and sit and wait for that to happen. Because the user will think it's broken. What we need is a way of continuing with all the other stuff that's going on, so the user still knows it's working, but then when that request is finished and we get an answer, then we can continue back on our other stuff. So web activity is really basically everything I just said. So this is an example of how it's done in C#. If we want an asynchronous method, we call it a task. So we say, this is a method we've designed that is going to be asynchronous. So we say this task of an int, access the web async. So here first we've got some normal code. This happens to be something that creates a HTTP client to actually do a request. Then we have this task here, which is client.getStringAsync, and there's a web address. So what this is actually doing is it's doing, remember I talked about yesterday about having a game that does a request to get a scoreboard or upload a scoreboard? It's a similar kind of thing. So there's a URL here. It's going to try and get the string from that URL and then return it here. But that might take time. So this is an asynchronous task. Then we have this method here that is just some other method that has nothing to do with this string. So it'll send off this request, but because it's a task, it's not going to stop. It's going to keep continuing. So it will do all the stuff that it needs to do here. And then it gets to this bit. And this has got the keyword await. So what await means is it's saying, look, I want you to wait until this task has finished. I need that string. So at this point, it's like, okay, I can't do this because this task hasn't finished. And then it'll continue. It'll know that URL.length, this, well, what it'll actually do, because this is a task, it will then say, right, I've got as far as this line. Now return to the rest of the code outside of this task, wherever this was called. It'll go out and continue the rest of the code. And then it'll keep checking to see when this is finished. And when it's finished, then this will actually execute. The rest of this will execute. This is something you're going to be using when you're working with databases and you're trying to add things to a database and you want to confirm that's happened correctly. So you'll need to like do a SQL statement or whatever and wait for a response. And there are lots of methods in the framework that are tasks. A mistake a lot of people make is Visual Studio won't stop you. You don't have to write a wait here. If you don't write a wait here, it's not going to wait for this task to finish. And then the URL contents is going to be null because the task hasn't finished. So that's a common mistake people made to watch out for, is to be checking if things are tasks or not. Okay, so I think that was a lot to go through. So I want to give you a 10-minute break and then we're going to move on to code reviews. So take 10 minutes and then back here at 11.